All right. Okay, so 12.8. So today we're going to be talking about solving general triangles. Okay, just like when we talked about solving right triangles. So when they say general right here, that means not a right triangle. Not a right triangle. Okay, because with right triangles you want to use the stuff that you learned in geometry. You want to use your Pythagorean theorem. You want to use your sines and cosines and tangents, okay? Inverse trig and regular trig. All right? So with non-right triangles, you're going to use your law of sines and law of cosines. So first, we learned about law of cosines. And then we learned about law of sines. So today we're going to talk about what kind of triangle or what information they're giving you on the triangle and when you'll use each of these first. So if you're going to use law of cosines first, it's going to be a certain kind of triangle. And when you use law of sines first, it's going to be another kind of triangle. So for triangles where they give you side, side, side. Not to be confused with SSS from triangle congruence. But you could think of it, if you want to abbreviate it on your own paper that way, just don't confuse it with that, okay? But yeah, if you want to shortcut it, go for it. The other one is the side angle side. And so if you see a triangle that either they give you side, 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 or side, angle, side, you're going to use the law of cosines first. In the other column, if you're given a triangle that is angle, side, angle, you're going to use the law of sines first. Or if you're given angle, angle side. Those two, you will use law of sines first. Does anybody remember the one from geometry that didn't work? What? Angle, angle, angle doesn't work, but there's another one. Hint, it spells a bad word.
ASS.
Right?
Oh, yeah.
Right? Okay. Spells a bad word. Okay, so
Yeah, that's a bad word.
put a little star, and so it doesn't spell a bad word on my paper, I'm going to write side, side, angle, right? This one is what we're going to call the ambiguous case. And if they give you side, side, angle, or angle, side, side, it may or may not solve your triangle. So this word ambiguous, it just means sometimes it's going to work out for you, sometimes it's not. Okay? Hopefully it does, but maybe it won't. All right? So this lesson, there isn't really anything new from what we learned from 12.6 and 12.7, which is good. Okay? So example number 1. All right, so example number 1. Here's your triangle. We'll call it ABC, but technically you could call the vertices whatever you want. And opposite A, we'll make it little letter B. This one will be little letter A, little letter B, little letter C. And so what are you given?
Side, side, side.
Side, side, side. So if you're given side, 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 should you use law of cosines first, or should you use law of sines first? Law of cosines first. Okay? So we're going to use law of cosines first. And so I'm going to write down one of the laws of cosine. Remember there were three, and just the A, the B, and the C kind of swapped places. Okay. So let's do A. A squared plus B, equals B squared plus C squared minus 2BC times the cosine of A. So if we know all three sides, what are we looking to solve for?
A.
All three angles, right? So the first thing we're going to solve for is angle A, right? That's going to go in here. So that's going to be this guy right in there. All right. So let's plug in what we've got. A squared. So we're going to plug in 12 and square it. E squared. So plug in 12 and square it. Plug in 13 and square it. So minus 2 times 12 times 13 times the cosine of A. Cosine of A is obviously what we want to solve for. So everything else we want to undo. 12 squared is 144. Another 12 squared is also 144. 13 squared is 169. Minus, let's multiply that out, 2 times 12 times 13, 312 times the cosine of A. So let's combine these two right here. Or, I can see that I've got 144 on both sides. I'm just going to subtract 144 from both sides, which cancels those. I'm also going to subtract the 169. So that leaves me with all this. That'll get me to solve for cosine of A. So negative 169 equals negative 312 times the cosine of A. My voice is getting scratchier as I go on. Okay, so we're going to divide both sides by negative 312. And because we're solving for an angle, do we use regular trig or inverse trig? Inverse trig. So we're going to say inverse cosine of that angle. Well, it's going to end up being a decimal. So negative 169 over negative 312. That's going to give us angle A. They're both negative. So when I type it in the calculator, guess what I can do? Both, just make them both positive. So we're going to go inverse cosine of 169 divided by 312. And I got 57-ish, 57.20. So let's go with angle A equals 57.20.
Wouldn't it be the same thing because the length's the same?
Yes. Okay, so she just figured one of them out. So if we figured out angle A, we'll go back up here, which is opposite 12, if it's 57.2 degrees, then angle B is going to be the same. And then angle C, just subtract those two from 180. So 180 minus 57.2 minus 57.2. What did I get? 65 something? 65? Double check that.
65.6, I think that's right.
Okay, so I did write it down. 65.6. All right, any questions on example number 1 there?
Nope.
So that one's starting off with law of cosines. Guess what the next one's going to be? Law of sines, right? law of tangent.
Yeah.
That was pretty funny, Javen.
Not even a thing.
No, but it was pretty good.
It should be just to make everyone.
Yeah, right?
Yeah, like discriminating against tangent.
All right, so we're going to have another ABC triangle. Angle A, we're going to go with 20 degrees. Angle B, 60 degrees. And side C is going to be equal to 10. So let's draw that out. Because obviously 2 angles and a side, but we want to see where it's at, right? So let's go with ABC, which makes their opposite sides little a, little b, little c. And then angle A is 20. Angle B is 60. And side C is 10. So this one is what?
Angle side angle.
Angle side angle. Everybody see why it's angle side angle? Okay. So we definitely want to use law of sines. And we've got A and its opposite side. We've got C, but we don't have its angle. But can we get its angle? Yeah, since we know 2 of the angles already, that means angle C is going to be 180 minus the 20 minus the 60. So that's what? I just got 100 yet. So now we've got angle C and its opposite. So we're going to say sine of A over A equal to sine of C over C. All right, so let's plug in our numbers and get our missing side here. Okay, so we've got sine of 20 over A, that's the one we're looking for, equals sine of 100 over the opposite, which is 10. There's our proportion. We can do our cross product. So we're going to have 10 times the sine of 20 equals A times the sine of 100. So we want to divide by the sine of 100 to get that A by itself. So there, the sines of 100 will cancel over here. And then we're going to type all of this into the calculator. And that's going to give us side A. So let me type that in. 10 times the sine of 20 divided by the sine of 100. 3. I got roughly 3.47.
Same.
Good. And so now side A over here is roughly 3.47. So we've got all 3 angles, we just need this one more side, right? So now instead of doing sine A and sine C, let's do, what did I do in my notes? C and B. I did C and B, okay? So sine of C over side C equal to sine of B over B. I'm just doing B because I had it in my notes, but could I have done A? Yeah. Okay. So sine of 100 over 10 equals sine of 60 over B. And then do your cross product again. So B times the sine of 100 equals 10 times the sine of 60. So to get that B by itself, we just want to divide both sides by the sine of 100. These cancel, and all this is what goes in the calculator, right? You can break that calculator work